What's up, everybody? This is Danny Mathematics again with another example to explore. And today, guys, I want to explore example 2 and example 3 of how to find the domain and the range of a graphic function. The domain and the range, right? And I have these notes, guys. Remember, the domain is the horizontal boundary, which is along the x-axis. So the domain is how wide, right, can the function expand, right? The range is the vertical boundary along the y-axis, right? So it's how high and how in depth, right, the function can expand, right? So how high and how in depth vertically that the function can expand, right? Based on the y coordinates that we have, okay? So let's go ahead and start off with domain. And once again, we're doing example 2, and then after example 2, I'm gonna follow it up with example 3. So remember, guys, the domain is along the x-axis, okay? And the range is along the y-axis, okay? So, as I continue on, guys, I've noticed that on both sides, guys, this function has arrows, right? These arrows mean that the function is continuous. Continuous. Right? That means that the function is continuous, meaning that even though we only have this portion of the graph, if the graph was bigger, the function would continue on, right? So the u will continue on, the parabola will continue on, right? So because it will continue on along the x-axis, right? That means that the domain along the x-axis is from negative infinity to positive infinity, right? Because these arrows is letting us know, guys, that it doesn't matter. The function is going to continue to go. And as it continues to grow, it will continue to expand along the x-axis, right? So the domain is from negative infinity, right? Because it will keep going. Negative infinity is less than x, right? And remember, guys, we can't never say that negative infinity or infinity is less than or greater than and equal to x, right? Because negative infinity and infinity are not really real numbers. It's just saying that the numbers are just getting bigger as it goes, right? So negative infinity is less than x, and x is less than positive infinity, right? Positive infinity. Or you can just say this, guys. The domain is all real numbers. The domain is all real numbers, okay? Now, remember, guys, the range is the vertical boundary, right? So I'm gonna see how low can we actually get, right? When it comes to this function. The lowest point of this function is actually at, and let's just say that's negative 2, right? It's actually at y equals negative 2. So this is actually the lowest point of the function, right? So y can't go lower than negative 2. So let's go ahead and put that side of the boundary, which is saying that negative 2, can y'all open the door? Negative 2 is less than or equal to y. That's what it's basically saying, guys. Negative 2 is less than or equal to y. But as you notice, guys, as we get higher, remember, this function is continuing on, right? So as it's expanding along the x-axis, it's also going further up along the y-axis. So because of that, the other side is going to be y is less than positive infinity. Okay, so this is going to be the domain. The domain is all real numbers because remember, as this parabola expands, right, it's expanding along the x-axis, meaning that it can expand all the way to negative infinity and it can expand all the way to positive infinity. The range, the lowest y value that we could become is negative 2, right? That's why it says negative 2 is less than or equal to y. But as you can see, as it expands and continue on horizontally, is going to expand and continue on vertically above -2. So on that side, it's going to be y is less than positive infinity. Okay? Now, example 3, same thing. Let's go ahead and start off with the domain. And remember, guys, the domain is the boundary along the y-axis, right? So I'm going to put x in the middle. Now, let's start on this side. Now, one thing I noticed about this function, there's no arrows at the end, right? Meaning that it's not continuous, right? So we do have a value that is the lowest x, and then we do have a value that is the greatest x that we can possibly become, right? So as I use the vertical line test to find out the domain, right? The lowest x that x can be is 0. X is 0, right? On the y-axis, x is actually 0. And as you can see, that's a closed circle. So x can be 0, or it can be any value that's greater than 0 until we get here, right? So we're going to put this guy, 0 is less than or equal to x. And then on this side, guys, we're going to find out what is the greatest x value that x can possibly be. So if I use the vertical line, okay, I have to stop right there. That's a boundary. Okay, so that's another horizontal boundary, and that's at x equals 5, right? So x can be 5, or it could be these values that are between 0 and 5. Okay, so that is going to be the domain. So 0 is less than or equal to x, and x is less than or equal to positive 5. Okay, so that's the domain, guys. All right, so this right here is the domain. This is the least that x could be. This is the greatest that x could be. All right, now remember, guys, range is the vertical boundary along the y-axis, right? So I'm trying to find out what is the lowest y. What is the lowest y value y can actually be? Okay, as I move it up, guys, the lowest y is at y equals -3. So this right here is a boundary right here, guys. And I'm just drawing these little green lines so you can see the boundary. So at -3, right? So y can't be -3 because that's a closed circle. So it's going to say -3 is less than or equal to. And I say equal to because that's an open circle. Equal to y. Okay, now we're going to go from the top, right? And we're going to find out what is the greatest value or the highest value that y could possibly be. Okay, the highest point of the function is at y equals +4. Y equals +4. So as you can see, guys, the function, the highest point of the function is at y equals -4, right? And that's a closed circle. So y is either less than or equal to a +4. Okay? So once again, ladies and gentlemen, we have our domain and we have our range of this particular function. So that's the domain, and this is the range. Once again, guys, I just want to go back over it. The least x value that we can possibly be within this function is x is 0, right? The greatest x value that x could be within the function is x is 5. So that's why we have x is greater than or equal to 0 and less than or equal to 5, right? And then for y, the least y value that y could possibly be is -3, right? And then the greatest y value that y could possibly be is +4. So that's why it's saying that y is greater than or equal to -3 and also less than or equal to +4. So this is how we find out the domain and the range of a function, which is the horizontal boundary and the vertical boundary. All right. So once again, this is example 2 and example 3 of how to find the range and domain. All right. Thank y'all so much for tuning in. I will upload a few more examples going over domain and range very soon. Thank you for tuning in. Have a great day.